Hey there, Miss Wallace here. I wanted to talk to you a little bit about the sun, the moon, and the earth. And so, what I have here is a doodles page that you already see information's filled in, but I want to kind of walk through this with you and emphasize some of the important concepts with these. So, we're going to actually start with the sun. It's over here on the right hand side. We know our sun is actually a medium sized star. Next week, I'm going to post a video that actually shows you, in comparison to other stars, that our sun's really not that big. It is about one of 100 billion stars in the Milky Way galaxy. It is the only star in our solar system, but there's a lot of other stars. We see those at night that are actually a part of our galaxy. So a lot of people think that the sun is on fire, that it's burning, but we know that it's not actually burning, it's actually glowing. And that's because what we see is the hydrogen and the helium gases the sun is made of. So what the process is actually a nuclear reaction. It's hydrogen atoms smashing into each other, forming these helium molecules, and that releases a ton of energy. That's called fusion. And there's also fission reactions going on where the helium is actually splitting back apart into the hydrogen. So both of those are going to release a tremendous amount of energy. Luckily, we get to reap the benefits of that energy in the form of heat and light that the sun gives off to us. Because the sun is the largest thing in our solar system, it has extremely strong gravity, and it's what's holding us in our orbit. And so you see here this line with that arrow. This is the Earth's revolution, or the orbit around the sun. We know our sun is made of gas. There is no solid surface, but it does rotate on an axis. So the sun is actually sitting there in the center of our solar system, spinning around on its axis. It is huge. You can fit 1 million Earths inside the sun, which is just incredible to think about. If we were to line Earth up across the belly of the sun, or the diameter here, you could actually line up about 100 Earths across it. But if we were to fill the volume up, it would take 1 million Earths to fill up the volume. So it's just incredibly massive. Extremely hot. We know that in the core of the sun, temperatures reach pretty close to 27 million degrees Fahrenheit. And they show you here degrees Celsius on the surface. So the surface is going to be a little cooler, but the core is extremely hot. So let's move further out and let's go to the Earth. Earth is the third planet from the sun. It is part of the inner four that are the rocky planets. It's the fifth largest of the planets in our solar system. However, it is going to be the largest of our rocky planets. So when we start, we'll look at the order of the planets next week. We have Mercury, Venus, Earth, and then Mars. Earth is going to be the largest of those four. It takes us approximately 365.25 days to go all the way around the sun. So we would call that 1 year. And it actually has a quarter that we can't forget about, because when we add this quarter up every 4 years, that's why we have a leap year. We have to add in an extra day. Because if we have a quarter times 4, we know that equals 1 whole, and therefore we have to add an extra day. So that day comes in at leap year February 29th, but it only happens every 4 years that we do that. So one term you need to make sure you understand is revolve or revolution. This is the Earth moving around the sun. It's not in a perfect circle. It's actually in an elliptical pattern, so it's more of an oval shape. The Earth also, as it's revolving, is rotating or spinning on its axis, and it takes us 24 hours. So about half that time we're facing the sun, that's when we have day. And the other half, when we're turned away from the sun, that's when we experience night. We are tilted on this axis at 23.5 degrees. And that's going to be really important when we start studying the seasons. As we move further into this unit, we'll look at how our seasons happen. As of right now, Earth is the only planet known to have living organisms. They've not found any other life on any other planets as of yet. But of course, scientists are extremely interested in trying to colonize Mars and planets that are close to us and that are solid surface planets. And then lastly, moving to the smallest of the three is our moon. We call it a natural satellite. Natural because it wasn't man made. There are tons of satellites orbiting our Earth right now, but they were all man made. So we're going to call the moon a natural satellite. It also orbits, as you see, it is going around the Earth. And it takes about 1 month or about 29 days to make its complete orbit around the Earth. Here it says 27 to 28, so you'll see kind of those different numbers, but uh, definitely 1 month time span. The gravity is only 1/6 of the Earth's gravity. So it does have a little bit of gravity. You're not going to just float off the surface of the moon, but it's going to be a lot less than we experience here on Earth. We will be studying the phases of the moon. You can see these here over on the left margin. There are 8 phases, or what we call the shapes of the moon. It's really what we see at night. And how much of the moon we see is just relative to where the moon is in relation to the Earth and the sun. And so we have special names for these that we'll learn later on. You see, here's an example. Here's the sun, here's the Earth, and so we would see this front half of the moon. The back half would be dark. Okay. We know the moon does not make its own light. It's really just a mirror in the sky, and it is reflecting the sun's light back to Earth, and that's why we see it. The moon also rotates as it's revolving around the Earth. However, it is rotating so slowly that we actually only see the same side of the moon as it's orbiting around us. So maybe Transformers was right. There is a dark side of the moon. Maybe that's where the Decepticons live. And then gravity, because it does have less gravity, it still has some. It's going to affect our tides here on Earth. So we'll talk more about that too. So our oceans rise and fall with the tides. So I hope you enjoy this unit. Lots to learn about the 3 of these, making sure that you understand the relationship between the sun, the moon, and the Earth.